Hello students, hello everyone. Welcome to Senior College Mathematics. Topic of discussion is indices. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAMB, or any other external or entrance examination into high school, this lesson is for you. You are in the right place. Pittacos Education Community. Lesson 2, Operations with Standard Form. In this lesson, we will learn how to add, subtract, multiply, divide standard form, and cases involving square roots. Before the lesson proper, for updates, follow Pittacos Educom via YouTube at Pittacos Simplified Maths. Just search for this. You get where we are located in YouTube. Alright, to do that, subscribe to this channel, like this video, share the video to your friends, your colleagues, your classmates. You can also follow us on Facebook at fb.me/PittacosEducom, Instagram at PittacosEC, Telegram t.me/PittacosEducom, WhatsApp through this mobile telephone number. In all of these platforms, you get updated from time to time about what is happening at Pittacos Education Community, where you have access to quality, unlimited, and simplified mathematics teachings in series. Okay, so let's start by looking at addition and subtraction. The easiest way to add and subtract numbers in standard form is to factor out the least power of 10. The least power, the smallest power of 10 between or among the given numbers. Express whatever form that is left in ordinary form. Your final answer should be in standard form. So let's say this. Examples. Simplify the following. Give all answers in standard form. Example 13. So you have this 3.4 times 10 power 3 plus 6.2 times 10 power 3. So if you share the two numbers in standard form, they have 10 power 3 in common. So you do well to factor it out. If you factor out 10 power 3 from both numbers, you are left with 3.4 plus 8.2. Sorry, 6.2. 3.4 plus 6.2. And when you add, you have 9.6 times the 10 you factor out. That is 10 power 3. You have added the two numbers and your final answer is in standard form. Example 14. 9.17 times 10 to the power of 5 plus 7.45 times 10 to the power of 6. The note says that you should factor out the least power of 10. So we have the two numbers. That is, this is the first number, this is the second number. Now if you look at the power 10 power 5 and 10 power 6, the least between 5 and 6 is 5. So what you factor out is 10 power 5. So the first number remains 9.17. If you factor out 10 power 5 from 10 power 6, the second number remains 7.4 times 10 power 1, because you remove 5 from 6. So 10 power 1 also means 10. So you multiply 10 by 7.45, then you have 74.5. You add it to 9.17, you have 83.65 times 10 to the power of 5, the one you factor out. You know this 83.67 is not in standard form. It's not in standard form. Okay, so to express in standard form, you need to move the point from where it is to between 8 and 3. Now this movement is backward. You are moving from right to left, that is backward. And if you are moving backward, the power is negative, so the power is positive. If you are moving backward from right to left, the power is positive. Here the point was moved once, so that one that is positive, if you add it to 10 power 5 now, you have 10 power 6. Then we have 8.367. 8.367 times 10 power 6. So our A now is 8.367 and is between 1 and 9 inclusive. Okay. Example 15. Example 15. You have this number is standard form. You subtract it with this second number. So you write out the two numbers. All right. We can do this in two ways. The first way is you convert this number to ordinary form. This power of -2, it means you move the point backward 2 times. When you do that and you fill the empty space with 0, you have this. Power of 3 means you move the point from where it is now backward 3 times and you fill the empty spaces with 0, you have this result. So when you subtract both numbers, you have 0.0276, and the result is not in standard form. For it to be standard form, you move the point again from where it is to between 2 and 7. When you do that, you have 2.76. Now the movement is forward from left to right. When the movement is forward, the power is negative, and because we moved 2 times, you have 2.76 times 10 to the power of -2. Or you have the first number, you have the second number. If you look at the base 10 and the powers of -2 and -3, you can only factor out 10 to the power of -2 because that is the least. Okay, if you factor that out from the first number, you are left with 3.6. If you factor out power of -2 from power of -3, you are still left with power of -1. And that power of -1, it means you move this point backward once, or you divide 8.4 by 10, and that is 0.8. If you subtract it from 3.6, you have 2.76 times 10 to the power of minus 2. So any of the approaches will give us the same result. Anyone choose to take. So let's continue. Multiplication and division of numbers in standard form. In multiplying and dividing numbers in standard form, note the following. What will you note? That 10 power A times 10 power B is equal to 10 power A plus B. This is the multiplication law of indices that we look at later. Then you should also note that 10 power A divided by 10 power B, you have 10 power A minus B. In other words, when numbers with the same basis are multiplied, their powers are added. And when numbers with the same basis are divided, their powers are subtracted. Okay? So these two rules are the multiplication and division laws of indices, as I said earlier. Okay? Examples: simplify the following. Give all answers in standard form. Okay? So example 16. You have the two numbers in standard form and you are asked to multiply them. So in doing that, because it's multiplication, we can take out the numbers and 10 and base 10 to one side. So you have 2 times 3, then 10 power 8 times 10 power 3. 2 times 3 is 6. From the first part, when numbers with the same basis are multiplied, their powers are added. So you have 10 power 8 plus 3. You have 6 times 10 to the power of 11. Example 17. You are to divide these two numbers in standard form. To make the work very easy, let us use fractional form, where the first number is numerator, division sign changes to division line, and the second number is denominator. So to make division easy, let us convert the numbers to whole number. If you express 6.3 in whole number, it means you have to move out the point. So if you move out the point, you have 63. Now the movement is forward from left to right, and you are moving once. So you are moving once. That implies power of minus 1 to base 10. So this is what you have there. If you do the same thing to 2.1, you have the same result. So from here, you see that 10 power minus 1, the numerator, can divide 10 power of minus 1 in the numerator. But I didn't do that here. What I did is that you have 63 times. From what we stated, when numbers with the same basis are multiplied, their powers are added. So from here, we have minus 1 plus minus 2, that is minus 1 minus 1. So you have power of minus 3. For the denominator, you have minus 1 plus 4, that is 3. Then you divide 63 by 21, you have 3. From the second version of the law, when numbers with the same basis are divided, that is these two now, their powers are subtracted. So you have 10 to the power of minus 3 minus 3, and that is 10 times, that is 3 times 10 to the power of minus 6. 3 times 10 to the power of minus 6. Okay, now this minus 3 here is the power of the numerator, so this minus sign is the difference. When number with the same base are divided, their powers are subtracted. Then the second 3 is the power to 10 in the denominator. That is what happened there. Okay, example 18, we have to simplify this. Multiply the first number by second number and by third number. To do this easily, if we convert all the numbers to whole numbers, that is 1.25, 0.125, 12.5, multiplication will be easy for us. So to convert 1.25 to whole number, it means you have to move at the point 2 times. The movement is forward. The power to base 10 will be negative because the movement is forward from left to right. This is what you have for converting 1.25 to a whole number. Then 0.125, you move 3 times forward, so the power is negative. So you have this. If you convert 12.5 to a whole number, you are going to move just once, and because the movement is forward, that power 1 is negative also. So this is what I'm saying now. Okay, so next thing, let's apply the rule. When numbers with the same basis are multiplied, their powers are added. So here you have minus 2 plus 2 for adding the powers, minus 3 plus 3 for adding the powers, minus 1 plus minus 4, that is minus 1 minus 4. Okay, so when you, the next step now, here becomes 0, this is 0, and we have minus 5. So 10 power 0 is 1, so here is also 1. So we are left with 125 times 125 times 125 times 10 to the power of minus 5. That is this 10. So if you multiply 125 by 125 by 125, you have 1,953,126 times 10 to the power of minus 5. Okay, that number is not in standard form. To put it in standard form, you have, because the number is greater than 1, you have to start moving from the end that is left to the right, that is between 1 and 9. The point should be here. So if you start from the right and you move here, you have 1, 2, 3, 4, 5, 6. Backward movement, the power is positive. So you have times 10 to the power of 6 times the other 10 to the power of minus 5. The same basis, you add the powers, that is 6 plus minus 5, and that is 6 minus 5, that gives 1. So this is what we have, 10 power 1. If we express this number to 2 decimal places, that means 2 numbers after the point, that is 95. So you have 1.95 times 10 to the power of 1. The next number 3 is rounded down to 0. So you have 1.95 times 10 to the power of 1 to the power of 1. Okay, example 19. Example 19, you have this number times this number. You can do it in two ways, that is multiply directly, but assuming you don't have calculator, so the best way is to convert the numbers to whole numbers before multiplying. To convert the first one to whole number, it means you move out the decimal point out 4 times, and the movement is forward. If it is forward, the power is going to be negative. So you have 664 times 10 power minus 4. For 0.025, you move out the point 3 times for it to be a whole number, and the movement is forward. That also means the power is negative. Okay, so let's take 664 and 25 together. Then let's take 10 power minus 4 minus 3 together. If you multiply 664 by 25, you have 16,600. The same basis are multiplied, the powers are added. So you have minus 4 plus minus 3. That means minus 4 minus 3. If you express this number now in standard form, for it to have a, the point must be between 1 and 6. So from the ending, the right, you move backward 1, 2, 3, 4. And because the movement is backward, the power to base 10 is positive. So you have 1.66, because the 0 now after the point can be ignored. So you have 1.66 times 10 to the power of 4. So if we add all the powers now, because the basis 10, they are multiplied, you have 1.66 times 10 to the power of minus 4 minus 3. Then this 4, you add it to it. That is what you have here. You see that minus 4 and plus 4 is 0. You are left with minus 3. So finally you have 1.66 times 10 to the power of minus 3. Minus 3. Example 20 is division. So let's follow the same steps in example 19, where we change all decimal numbers to whole numbers. So if you change 4.56 to whole numbers, you have 456 times 10 power minus 2. If you change 3.6 to a whole number, you have 36 times 10 power minus 1, because you move out the point once. You change 0.12 to a whole number, you have 12 times 10 to the power of minus 2, because you move out the point 2 times. So here we can quickly and easily divide this by this. And if you divide 36 by 12, you have this 3 here, multiplying 456, and this 10 that is left. So 456 times 3 is 1,368 times 10 power of minus 1. Okay, at the stage we are now, 1,368 is not in standard form, so we have to write it in standard form. Since that number is greater than 1, it means you are moving backward. The point should be between 1 and 3. That is where it is now. So if you move from the ending, the right, to where it is now, you have 10 to the power of 3 times 10 to the power of minus 1. So when we apply the rule, when numbers with the same base are multiplied, their powers are added. So you have 3 plus bracket open minus 1, and that is 3 minus 1, and that gives 2. So we have 10 power 2. So we have 1.368 times 10 to the power of 2. I'm doing this way because I'm assuming you don't have a calculator. As a matter of fact, if it is theory question, you need to show your workings. So that is why we are taking time to explain and show the detailed solution step by step. All right. Cases involving square roots. Cases involving square root. The only thing to note here is that the square root of any base number can easily be written as the base number to the power of half. So square root means power half. If you have cube root, it means power of 1 over 3. If you have fourth root, it means power of 1 over 4, and so on. Examples: 21. Without using mathematical tables, evaluate square root of 0.81 times 10 power 5, 2.25 times 10 power 7. If you are conversant with a perfect number, you will know that 81 is a perfect number. So it is easier to get the square root of 81 than the square root of 0.81. The same thing applies to 2.25. So what we do is to convert the decimal numbers to whole number. So if you convert 0.81 to a whole number, it means you have to move out the point about 2 times. The movement is forward, the power to 10 is negative, and you are moving twice. So 0.81 becomes 81 times 10 to the power of minus 2 now, times 10 power 5, the one you have in the question. Okay, for 2.25, the same thing. If you move out the point 2 times, you have 225 times 10 power of minus 2, then times 10 power 7, the one you have in the question. Straight ahead, you can divide 10 power 2 minus 2 by 10 power of minus 2. So those two terms are gone. Then we have 81 over 225. For the remaining terms, base 10 is being divided. That means you subtract the power. That is 5 minus 7. 5 minus 7. If you subtract, you have power of minus 2. Square root of 81 is 9. Square root of 225 is 15. But you cannot check the square root of this term. So you convert the square root of this term to power of half in this form. Okay? If you reduce 9 and 15 by using 3 to divide, you have 3 over 5. Then so here the two power can be multiplied together. So you have minus 2 times 1 over 2. That is minus 2 over 2. And you have minus 1. If you divide 3 by 5, you have 0.6 times 10 power of minus 1. 0.6 is not in standard form. because 0.6 is less than 1, but your a must be greater than, greater than, it can be 1 or greater, so it can be between 1 and 9 precisely. All right, so to change 0.6 to a whole number so that we can have standard form, you move out the point once, and the movement in that case is forward. So if you move out the point once and in forward direction, the power to 10 will be -1 before the second 10 to the power of -1. Okay, so you have 6. The same basis, the powers are added. -1 plus -1 means -1, and that is -2. Finally, you have 6 times 10 to the power of -2. Are you following? Okay. Example 22, simplify without using tables or calculator. Like I said earlier, if you are conversant with perfect numbers, you will know that 16, 81, and 36 are perfect number whose square root you can get easily. To do that, you have to change the numbers to whole number by moving out the decimal point respective number of times. The 3 numbers, the movement is forward. That means the power to base 10 is going to be negative. For the first one, you have this result. If you move out the point 4 times, you have 16 times 10, power of -4. The second number, you move out the point also 4 times, you have 81 times 10, power of -4. For the denominator, you move out the point 2 times, you have 36 times 10 to the power of -2. Okay, so we have 16 times 81, then 10 power 4 -4 times 10 power -4 over the denominator. So we have it in this form. Okay, now the two base, in fact we can combine the 3 base at the same time. These two, the powers are added. When we come to this, you subtract the power. That is -4 plus -4. That is the same base multiply. Then minus, now this minus is for division. Then -2. When we do that, we have -4 -4. -2 is +2. -4 -4 is -8. -8 plus 2 is -6. After achieving this, we can now find the square root. Square root of 16 is 4. Square root of 81 is 9. Square root of 36 is 6. But you cannot check the square root of this 10. So you convert the square root of 10 power -4 to the equivalent of power of half, so that the power of -6 times 1/2 becomes -3. If you multiply 4 by 9, you have 36. Divide by 6 is 6. So you have 6 times 10 to the power of -3. Hello. All right, so it is how you add, you subtract, you multiply, you divide, and even resolve. The cases involve square root is mainly combination of multiplication and division operations. All right, end of lesson 2. Thanks for watching and learning. with Pentecost Education Community. Don't forget, watch out for more from the Voice of Pentecost. For questions and inquiries, use the comment section. I promise you I will attend to them. You want to learn anything that I have not touched so far, you can also drop it there. For the complete package of this topic, lesson 1 to 9 for offline usage, contact the Voice of Pentecost via this WhatsApp number or through the email address. At a very little token, you get the complete package delivered to you. If you are not safe, your life will be in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, I tell you big congratulations. Live righteously and be prepared, because on the last day some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely, and the Lord will bless you. Ladies and gentlemen, gentle boys and girls, goodbye for now.